Hello everyone. I welcome you all to this introduction course to data science. We will start with the famous and renowned quote by John Owen. Data is what you need to do analytics and information is what you need to do business. So as said, if you are doing your data analytics job, data crunching, data munching, and you are using the data to derive the business, and unless and until it is not generating the value, it is of no use to business. So you can use the data to uplift the business, to get your sales revenue increased by some amount, to get more opportunities to your pipeline. That's where the data science main contribution is. And these days we are seeing that AI and data science is disrupting each and every industry, whether it is banking, BFSI, banking, finance, and insurance. Data science is getting used, whether it is healthcare, whether it is aeronautical space, whether it is IT and whatnot. So it is widely being adopted in each and every industrial sector, be it manufacturing, be it like non-core job or whatever. Everything is getting replaced by data science. So what do you expect from this course? Is it a definitions? We will look at what is data science, what is machine learning, what is deep learning. No, this course is not about reiterating or the things that are on Google. One can easily find the definitions and reiterating those in the course. This is not that course. Okay. So we will go on a journey that is meant to understand what is data science by making you contemplate, by making you imagine the scenarios, what I will describe. I will make you go through that journey and like you will imagine all those scenarios in your mind and you will like get to know that this data science concept is nothing new. It is very old concept which is getting widely adopted these days, and how that boom happened, how that things are shifting towards the data driven decision and things like that. So I just need your strong imagination power. We will set a journey and we will see a bigger picture, and you will understand all the concepts. What you After doing this introduction course to data science, you will understand what is data science, what is machine learning, what is deep learning, how they are different, and what are the different kinds of data is available to us. And also you will get to know about the roles differentiation, because mostly people are getting confused or they are mixing up some roles which is predominantly into the data science domain, such as data scientist, data analyst, business intelligence, and whatnot. So we will see each and everything in this introductory course, which will clear your all questions that you have related to this field of data science. So let's get started. Hi, I welcome you back to this course, and we will start with some basic questions that you are also getting confused while studying or while reading about the data science. What is data science? Who is data scientist? What does he do? What is the role of data scientist and things like that? So what is the difference between data scientist and data analyst and the business analyst? And everything we will see at last, and it will all get clear what what questions you have in your mind right now, and it will get solved. So starting or going to our next slide, uh, this is usually you will find in every introductory course, which will start with the definitions. What is AI, what is machine learning, deep learning, reinforcement learning, and the computer vision, and they will just explain the meaning of that. But this course is not like that. I will not reiterate the definitions that a one can read from the Google and can understand. Will not start with the definitions. Rather, I want you to come like set a journey for you and imagine the things that I want to do right now. So I just want to do a simple task, a very simple task of yours. Just imagine your daily routine. What is your daily routine looks like? And it should be starting up with the morning routine. Okay, so I'm taking you or setting up a bigger picture for you. So just imagine what is your daily routine after you get up in the morning. Okay, so We'll start with that. So, if you are a person who wakes up in the morning and you do either of these three things, and I can bet like all these three things that I have defined, like 95% of the people will fall under these three. Okay. So, just imagine you wake up in the morning. What is the first thing you do? You can either speak in the sense, yeah, you can like wish a good morning or good evening, or your parents can wish you the same, and you being the listener. So either you can speak to someone, your roommate, your friends, your colleague, to anyone. That is the first thing you will like. Wake up in the morning, you attend a call and you will speak. So that is, you will have what kind of data? That is what more important. That is the speech data. Okay, like you are speaking to someone, or you are either listening to someone. Second scenario, you wake up in the morning, you just had your phone in your hand, and you read some of your notifications that you have. You can read your emails, you can read your tweets, you can see your Instagram posts and things like that. what Whatever. Okay, so what kind of data is involved in that? And you have guessed it right, that is textual data. You are reading something, you are reading a mail, you are reading a tweet, you are reading your LinkedIn post. Everything that you see there is in form of textual data. The third scenario, you pick up your phone and you just clicked a picture, or you just uploaded a picture on the Instagram, or you just opened the Instagram and scroll through the images. So that is the third kind of data that you are seeing, that is either a video or a picture. And I can bet 95% people are using these three dominantly like there is nothing more classification of data. A data can either be in speech format, or you can say the audio format. Either it can be in textual format, number format. Number is what we can calculate, we can do operations, and the textual is something which we have as a textual data, that is sentences. And third one is we can have either images or we can have videos. So these three scenarios, or these three categorization of data is only possible, nothing else. Your data is divided into these three bigger chunks, and everything that you like read, everything jargons, every other word you will read about the data will be categorized into any of these three. Hi, I welcome you back to this course. So now we have understood that the three major categorization of data we can have is either you can speak or listen, that is your audio file involved or audio speech is involved. Second one is either you can read a text, you can write a text, you can write a number, numerical data, you can perform calculations. So that is nothing but your numeric data or textual data. The third categorization is you can either click your photos, upload the photos, watch the videos on YouTube and things like that. So that is your third categorization of data. So you have understood that we are like from morning till night, we are equipped with these kinds of data, nothing beyond. So we will speak to our colleague, to our friends, to our bosses. We will read something, we will write something, we will watch something, and we end our day. So these are the three data points that a human generates at each and every second of his time. Correct? Now coming to the definitions part so that it could make you more clear. The first one for the speech is speech data, or you can say for the in what we call these as a smart assistants, or we can call it as intelligent virtual assistant in the language of data science, IVA in short form. So the definition states that artificial intelligence is intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals, which involves a consciousness and emotionality. So these days we are having these devices called Alexa, Siri, Google Now, and Cortana, which can understand the human speech. You just ask the question to them and they will answer you in the natural language. You ask them what is the weather today, what is the score of the match, and they understand each and every word that you speak, and they comprehend that speech into their backend system, into the text. They will get an answer and can get back to you within speech. So this is like evolving these days, and you can do endless things using your Alexa. You can control your home, you can control any operations using voice, you can listen to music and things like that. Second one, the natural language processing. This is another definition, or you can say the branch of data science, which is natural language processing. And as the name suggests, you are processing what? A natural language, a textual form, a written form, which you have in the data. So natural language processing is a subfield of linguistics, computer science, and artificial intelligence concerned with the interaction between computers and human language, in particular, how a program computers to process and analyze large amounts of natural language data. So these days, this kind of data is getting widely adopted because in one study, or you will see in my next slide, in Gartner's study, it is mentioned that 80% of the data is mostly in your unstructured form. And what I mean by unstructured is it is either in terms of or in form of textual or in terms of video or photos or things like that. So that all are your unstructured data, and 80% of the world data, okay, everywhere data is natural language. So what is an application of natural language? So you can derive a sentiment from the comments. You must have bought something from Amazon and Flipkart, and you see people reviewing that item. So you can take a natural language response over there. You can build a model and you can have a sentiment whether the user is happy or not. And companies are really using those sentiment analysis in everywhere, because you can find a review in each and every website. Either you book your hotels on Make My Trip, either you book your houses on Airbnb. Everywhere you'll find the option of review, and based on that review we must take a decision. Okay, we do that. If a property is rated 4 star, 5 star, we usually read the reviews before booking anything. We usually read the reviews before buying anything. So that is the power of natural language, and you can take it to next level. You can build your question answer module. You can take your, like, you can bring your sentiment analysis. You can do your neural machine translation. There are various languages you want to translate from one or the other. You can do speech analysis and whatnot. Coming to third point of images data. So data image processing is use of a digital computer to process digital images through an algorithm. Computer vision is interdisciplinary scientific field that deals how the computers can gain high level understanding of the digital images and videos. So we have images, we have videos, which is nothing but frames of photos only. So videos are nothing but the frames of your pictures only. So you can process these images, you can make a conclusion out of that. You can even detect, in a healthcare, you can detect cancerous tissues or tumors which are not visible to a human eye, but a machine learning algorithm can differentiate those patterns and can get whether the person has a cancer or not. You can use images for self-driving cars, for detecting any like anomaly in the product and things like that. So all three of these data, and like whatever you will see now, it's the application of these three data. Either you are using speech data, which is governed by Alexa, Siri, and these virtual assistant. Either you will use the textual data to do some sort of solving some problem, or either you will use the images data to again solve some bigger problem or bigger challenge. So I hope this makes you understand what is happening in data science world, and everything that you see around is one of the other application of these three datas. Hi, I welcome you back to this course. So now let's get started of the journey. We have set the bigger picture. Now let's see what is data science and the data categorization. So data science is an interdisciplinary field that uses these scientific methods, processes, and algorithms. So this is nothing new. Algorithms are existing from, I guess, past 20, or you can say past 50 years, when when the world of software engineering hit a market. So algorithms are existing from long back, And it's just that we are using the application of algorithm to solve a problem of data science. So, and if continuing to definition, it's a algorithms and systems to extract the knowledge and insights. So that are like really two important words. You what you want to do with the data. What is the need to do data analysis or data science? You need to extract the knowledge and insights. So that is the whole purpose of doing data science. You have to extract knowledge and insights from any kind of data. That is, it can be structured data or it can be unstructured data. And data science is related to data mining, machine learning, and big data. So we will see those jargons and terms. So now the term one used is you have to find the knowledge. And in terms of data science, we call it as KDD, knowledge data discovery, in terms of data mining. So that is what we want to achieve and find the insights. Now, coming to the data categorization, we can either have the structured data or unstructured data. Now let's see the difference between those. So the structured data is quite simpler one, or you can say that is being used from like past several years. You have heard of Excel files. You must have used your Excel files. So that is nothing but your structured data. Structured data has the rows and columns. So you have those kind of tools. You have Excel, you have SQL databases in which you have a table like rows and column structured data that is stored, and you can do anything based on the data you have. So if it is like sales data, revenue data, you can find average, you can sum all those, you can do any kind of perform like statistical analysis on that kind of data. So that is something which we already know, which we have worked on, structured data. On the other hand, the unstructured data cannot be represented in the form of rows and columns and relational databases. So we have special kind of data to store our images, videos, and which is like NoSQL databases. Okay. Coming to the second point, so as we have said, it can be of number, dates, and strings. We have like sales category, what items are getting sold on each day. So we have dates, we have string as a product name, we have numbers as a quantity that is being sold by as an example for company's data. On the other hand, in unstructured, we have images, audio, video, word processing file, emails. Emails is nothing but your, again, textual data that is coming, spreadsheets, etc. And as I highlighted this fact in my previous video, so estimated only 20% of enterprise data is in structured form and the rest 80% is in unstructured form. And that is quite evident, like mostly if we see around us, all the knowledge is present in terms of textual format. So textual data is predominant in terms of when we talk about any industrial data. So we read lot of information on the internet, we write lot of information on the internet. So all is getting stored or all is getting processed in terms of textual data. Coming to the fourth point, obviously structured data is a numeric, an integer, and strings. So that requires very less storage. So that is like less extensive to the compute resources. On the other hand, your unstructured data require more storage, more space in your hard disk, and this is quite resource extensive. The last point is easier to manage and protect the legacy solutions. So we can have like data privacy, we can have the unlocking of, we can say, we can save our files in such that it is not getting unauthorized access and things like that. But the textual data is difficult to protect, or we can say that is widely accessible to the people around you or around any social media platform. So your textual information, your photos, your videos are quite prone to data privacy, or you can say cyber threats. Hi, I welcome you back to this course. So we have seen and set a bigger picture of data science. We have seen structured versus unstructured data. So now coming to this very famous pyramid of data science is the step, or you can say the procedure to reach at the wisdom level. So simply data science is a study of data and it is often confused with the data mining. So in terms of data mining or data extraction that you want to do or perform some analysis, The first is kind of a raw data, which is of no use to business. Data is being collected at various stages of the company, or you can say various stages of the industry. It can be collected on sales level, marketing level, on product level. What is the issues behind the product? You can have the logs data, you can have the web analytics, social media analytics, and whatnot. So you have the raw data in terms of anything, okay, like that is widely being captured by the industries. Now, the second step after capturing or after having the raw data is to find the information out of that data. Information is nothing but you are using the relevant data and discarding the rest. So you are using what is relevant for your business use case that you are solving, and the rest you are discarding. And after just figuring out which all data, or which all you can in terms of rows and column, you can imagine which all features or column you have in your data, you call it as your information. And then using that information you are deriving some knowledge. Okay, so deriving some insights, some knowledge, that is again helping your business to uplift and increase some sales or revenue, or do some better performance. So when that is achieved, that is you are going to the stage of wisdom and you are achieving that criteria. So let's come to our next slide. So now we have a discussion on machine learning, a famous word these days that is being used widely across industries. So machine learning is the study of computer algorithm that improve automatically through experience. It is seen as a part of artificial intelligence. When we say that the algorithms that improve automatically through experience, so I will give you an example that you can correlate with the machine learning thing. Imagine a newborn baby. Okay. So he knows nothing about the world. It is just he's a newborn and he's just came to this world. He will or she will eat whatever is fed to him. He will pick up anything, like whatever you give to a child or a baby, he will just pick up. He doesn't know whether this thing will hurt him, or whether if he touches the fire will hurt him or not. He will do out of the curiosity, he will do. But once he put his finger on the fire, he'll get some pain that will come back to his mind as a pain that is not a rewarding thing, and that is the experience he is getting stored. So a child when learns anything new, he must be learning how to walk, how to ride a cycle. He, like many times he will fall down and he will learn how to ride, like learning through experience. So that is what machine learning is. A machine learning algorithm learns from an experience, learn from the data that is fed into the model. So this is the concept of machine learning. And through this concept, we have divided the machine learning into three major categories: supervised learning, unsupervised learning, and the reinforcement learning. So we have seen three categorization of machine learning algorithm. Now we will discuss each one of them and we'll see what's the difference among all three. So first we will start with the supervised learning. So as we have said, machine learning algorithm learns from the experience, learns from the past data, and it will try to improve itself by using the data at the backend. So we'll see what is supervised learning. So like what's the difference between, you can see that these can be anonymous, supervised and unsupervised. So in supervised learning, you have the prediction that you want to do. So you have that target variable with you given what you want to predict. So a very famous example, I would like to imagine you again. Imagine you want to buy a house in your locality. So what all things you will see as a buyer, you want to purchase a new house. Just a simple question: what all features, what all attributes, or what all you can say, like while buying a house, what you will see in that house, like what are your expectations? So let me describe some, and if you have thought about that, that's really good. So let's discuss some bigger, or you can say some major ones. The first one is the area of the house. That is like biggest thing. You want to buy a 2 BHK, you want to buy a 3 BHK according to your needs, according to the money you have, and things like that. The first one is the area that you want to buy, the area, square foot area of the house. Second is you will see the locality. Third, you can see the like uh, like how recently it was built. How is it of a modern style, or it is very old, built like 10, 12 years back, or it is just recently built 2, 3 years back, and things like that. Okay, so how old is your houses? Third is whether it is located centrally, like all the facilities that you need, a supermarket, a railway station, a bus stop, and like commuting services are nearby to your house that you can see, and things like that. So those were some bigger level features that we actually see when buying a house. So in terms of supervised learning, in terms of supervised, again, it is classifying into two, classification and regression. So this example that I have taken, the first one of house one, is of regression type. So what how machine learning model will, and like first of all I will continue my example. So these are the features that you have in your mind. So you go to your broker and say I want to buy a 3 BHK, and it should be centrally located, and it should be new house, like max to max 2, 3 years old, and things like that. So based on the information that you provided to your agent or broker, the broker will tell you that this house is located in XYZ locality and the price of that house. So what is the deciding factor of you buying or not? That is price. So if that price falls under your budget and you like the house, you like the locality, you like everything, every other thing, you will buy that house. So that is the target variable that you are taking your decisions, you are making your decisions whether to buy or not based on the prices. So that is your target variable that your algorithm will predict. So that is the case of supervised learning regression problem. You want to predict a house price, okay, based on the information provided. So now how algorithm will predict? Like it doesn't know. How algorithm is not a broker. Algorithm cannot tell you what is the price of the house. So based on the past data that you will feed to that algorithm will help the model or help the algorithm to build the model on those data, and in future points it can predict the house prices. So let's say you have in your area, or in that area you have 100 houses, you have the area of that house, when it is built, and you know the price of the house, you know the target variable, you know the price thing. So you have 100 rows, you give it to model, that a machine learning model, see this is my data, this is my features, and this is my target price that is coming out, learn it. Okay, you are telling a machine learning model to learn it. That is what we call machine learning. Machine is learning the patterns of your past data. And now once the machine has learned, you have evaluated your model with good performance, AUC and accuracy. Now you can predict the predict the price of a new house. So you just have to feed in your area, where it is located, and when it was built, like how old is your house, and it will predict you a house. So that is the prediction model, and which is a regression one. Second example of is of classification. This is a little bit of different, in which we are not predicting any continuous variable that is price, but either we are predicting a binary classification or multiple classification. So when we say binary classification, it is just two. Okay, so it various example of it is whether the person will default a loan or not, whether this picture of a cell or some tissue in your body is cancerous or not. So that is binary, either yes or no. And if it is a multi classification, you can have, like in terms of sentiment classification, you can be either happy, you can be sad, you can be neutral, you can be joyful. So that is like multi classification. So as we have mentioned in our examples, the diagnostics that I have taken example of cancerous tissue, you have customer retention, you have image classification, whether the image is dog or not, simple, yes or no, whether the image you fed to the model is a dog or not, and identity fraud detection, whether the person will default a loan or not. So that is one example of banking, one of healthcare, one of marketing, one of images, and things like that. So we have covered the supervised learning in full details, And you can see in our regression also we have few examples, like you are predicting the advertising popularity, you are predicting the weather forecast. Nowadays we have the weather forecast which tells us the temperature of full 1 week, what will be the temperature in next week, so that is we are predicting. Market forecast, you are forecasting the market, what will be the response of your customers and the market, how it will react. Estimating life expectancy, you have stock market prediction, which is also a regression problem. You are predicting the price of some stock, you are buying at rupees 100 but you are predicting it can go up to 150, so your machine learning model can predict a house price, stock price, using the past data of that stock or the performance of stock and whatnot. So all those are features that has been set or sent to the model and it is predicting out. Hi and welcome back to the course. So the second classification after seeing the supervised learning, we have the unsupervised learning. And as we can see that these are synonymous and antonyms to each other. So we know that the difference is the target variable is missing here. So we don't have any target variables in this kind of algorithms. So in unsupervised, we have everything, but we don't have the target variable. Like in our previous case, we have the house prices as our target variable, which we want to predict. But in these cases, we don't have any target variable. So as an example, the recommendation systems. These days we find all these systems in at Amazon, at Netflix, the movies you watch, and it will recommend based on the data they have. So how they will recommend? So they will match your behavior, they will match the previous data, that if a user has bought item A, so they will see that that is like a whole different market basket analysis that they do. So they see that in their previous records, with an item A, mostly people bought item B. So it will recommend you that may you like an item B so that you can buy. So it is trying to cluster you into the same bucket, or you can say into the same bunch of people whose behavior is similar to you. So let's say on the Netflix, you mostly watch romantic movies and the comedy movies. So the algorithm will predict that what kind of a behavior you have, what kind of movies you watch, and based on your interest, they will recommend you the next best movies that you can watch. So that is the power of unsupervised learning, and we call it as a clustering. So they can target, that can be used for target marketing. So based on the behavior matching, they will target the group of audience using some similar activities. And of course, customer segmentation. They can segment whether these customers are our happy customers, these customers are our medium customers who bought like little less, and these are our like really bad customers, you can say really low profile customers who rarely come to our site and purchase an item. So there is classification or segmentation of the customers. The second one, we have an application in dimensional reduction, where we reduce the dimensions of the big data or the data which has like various features. So you can just understand that if a data has 2000 features, 5000 features, attributes, you will see which are correlated, which are not relevant for the application you're solving, and you will reduce the dimensionality using your unsupervised approach. The third one is very interesting one, the reinforcement learning, and which we have taken an example of a child. This is very similar to that. A child is learning his from its behavior or from its experiences. So a child know once he put his hand in the fire that this thing is not a good one. This gives that this thing or this activity can give a pain. So that is the experience that has been stored in his mind, and he will refrain himself from doing that activity again. Similarly, the reinforcement learning is kind of a same behavior, perform the data into the same behavior. So it will learn according to what the steps are there, and it will have the penalty associated and the rewards associated. So if it is a good thing or a good performance, if it has increased, something has been done, some activity is done, and it has been a good thing, so it will reward it. But if it turn out to be a bad thing, it will penalize it. So that algorithm is learning what is good, what is not. A very famous example, a chess game or go player game that has beaten the human in the game of chess, there are some other games. So that algorithm has beaten the human in terms of playing. So algorithm learns by like reiterating different steps, that whether I move this step, so what I'm losing, if I do this step, what I'm gaining. So a machine can store all those patterns inside that. So that is like they have defeated a human in a chess competition. The algorithm has defeated that. So that is what we have, reinforcement learning. It will learn itself. It will penalize if the move is wrong. It will reward if the move is great or giving some great output. So this is the product categorization of machine learning. Let's see our next slide. Hi, I welcome you back to this course. So the next thing after seeing the product categorization, we have some examples, some very fascinating examples. So I really want to discuss the first one. The thing is, there has been a study done by Forbes and some greater, you can say, the supermarket giants such as Walmart. So they have seen a unique pattern in terms of their selling items. So in terms of data science, we have something called market basket analysis, which it does it, they will place certain items in such a way that has a high probability that they will sold together. So you can, let's for example, think of a bread and butter. Okay, this is the usual breakfast in our Indian families where if we are buying a bread or if we are buying a butter, there is a high probability that you will buy a bread too, so that you can have a bread butter. Similarly, if you have a cornflakes, it's a very high probability that you will buy a milk too, because you will eat the cornflakes with the milk. So that is complementing each other. So these products are complementing each other, and there is a probability, high probability, that these two will sold together. So you can place those items in a shelf like nearby to each other. But there is some very unique pattern that they observed, like it cannot be thought in our minds, like it's completely based on the data. So what they observed that whenever a father is coming to buy a diaper for his baby, or a male is coming to buy a diaper for his baby, they have observed that in a cart they always have a cart of beer in that. So what they did analysis on, you can say, past 1 lakh records, 1 lakh transactional records that they have. So these giants produces bill when you check out from DMart, from your big bazaars. So they will give you a bill, they have your information, what items you have bought. So they studied all of them, and they found that in mostly 90 to 95% they have found the association. In terms of market basket analysis, we call it as association between these two items. So they found that whenever a male father is coming to buy a diaper, they find that a carton of beer is always be there in the cart. So they have produced this as a cross sell options. If a father is coming to buy a diaper, he will buy a beer. So they have placed their items in such a way that it is boosting their sales. So that is like really unique pattern that one cannot even think of, but using data it can be proved. The second is when we go to supermarket or when we are buying at Amazon, we see that a person buying X item is recommended item Y that is complementing to that item. So let's example, if you buy a DSLR camera, you will see in the recommendation either a tripod or either a memory card, because these two products are complementing your DSLR camera, and which you might require in your future to click the photos. You must be needing your memory options, memory card, and things like that. The third example is your Netflix recommendation. You watch certain kind of movies and it will recommend based on your experience or based on your interest what you would like to watch next. So now this is the person, like I would have hidden his name. First of all, I would have asked you that this person is called the father of deep learning, and his name is Jeffrey Hinton. So this person is working on this deep learning concept from, you can say, several years ago, and he has developed certain algorithms in deep learning, and he was a researcher at Google earlier. So he's called as a father of deep learning, who has really made a breakthrough in this era. So we will start now a discussion on deep learning stuff. How deep learning is a little bit of different from the machine learning. So how does deep learning has been evolved? So this is the picture I have included in 1956. This is the size of a hard disk. Yes, this bigger size is a hard disk, and to tell you the fact, it is just 1 MB of space. So you can imagine that 1 MB of space in 1956 was this much bigger. Then coming, or we gradually progressed to the 1980, that is 10 megabyte of hard disk, and see the cost. The cost is around 3,000 for $95. And today, or we can say the modern era or 2000 century, we have a 256 GB memory card, that like very small memory card of 256 GBs, and the cost is just $149. So that is how we have progressed. And in terms of science, we call it as Morioh laws, which is telling you the amount of transistors that are keep on adding into the chips, and we are evolving from the like past 1956 to 2000s. And how does this take a shape? And because of this paradigm shift only, the deep learning is happening, because we need a high resource of computing to perform a deep learning. So that is now possible because we can have extensive hard disk, we can have GPUs, we can have CPU, RAMs, and things like that, which is all based on memory devices. So now is it possible to have this deep learning algorithms really working. Hi, I welcome you back to the course. And now we will see in this slide the foundation of deep learning. We have already covered what is machine learning. We have seen some examples, well, very fascinating examples, how data can derive such patterns. And now we are jumping towards the deep learning. How deep learning is different from machine learning. So in terms of deep learning, this is nothing but a mimicry of your brain. It's just a mimic version of your brain. How does a human brain or any species brain perform? So we have a foundation of deep learning, that is the neurons. That is what the name derived neural networks, which are the heart of deep learning. So neurons are also called neurons or nerve cell, are the fundamental units of brain and nervous system, and the cell responsible for receiving sensory input from the external world and sending a motor commands to our muscles, and for transforming and relaying the electrical signals. So that is like really understood biological concept that we have in our brain. So we have several neurons in our brain that is responsible for communicating, that is responsible for understanding and taking actions based on the information. So dendrites, neurons, and axon we have in terms of neurons in a human brain. So neuron is the middle part which stores the information, and dendrites are the, you can say, receivers, and axon is a transmitter. So these are like complementing to each other, and they are like receptors, and they transmit the information, they receive the information, and the cycle keeps on working. Now let us see how the deep learning neurons looks like. So these are our, like these neural networks is nothing but a black box kind of a thing for you, but these are generally mimicked as a human brain. So as neurons are connected inside our brain, so these neurons or this neural network is connected to each other, and we have the input layer, which is nothing but the features, we have hidden layers, and we get the output of that. So let's take our previous example of predicting a house price. So let's assume that your feature one is area of the house. Your second feature is how old your house is. Like, is it 5 years old, 10 years old, 15 years old, and things like that. And the three is whether it is centrally located in the market, and just like that. So just we have three features, and based on hidden layers, we will predicting the house price. So now you can imagine that you can have a different values for all the features. Let's say you have 250 square meter of area, you have 2 years old house, and you have centrally located, yes. So that is how fed into the network. It will go through all the data, all through the combinations. So these are like all combination it will go through based on the features that you have provided, and it will predict the house price. So why deep learning is happening, or why it is come into existence when machine learning was there? So it is observed that when we use these intensive networks, like these hidden layers, it is just not one layer. We can have multiple layers. We can have 20 layers, 30 layers. And when you see that all the combinations of different weights that has been uh, doing in this deep learning stuff, so you get a better prediction. So the model's accuracies has been increased when we use deep learning as compared to machine learning. So that is the main reason why deep learning came into existence. So as you also know that the dominant feature in deciding the price of your house is area only. So based on area only, it will be a deciding factor. So the dominant one is feature 1, less dominant will be feature 2, and more than less will be feature 3. But that is on our, you can say, our human instinct. So what does model will learn? That will tell you the real thing. So we know that feature 1 is the most powerful one. So you can calculate the feature importance and get to know that feature 1 is driving the sales or your prediction of the house. So that is the power of deep learning, that can try different combinations of weights, and it will come to the optimal stage by doing back, like these are the we will see in detail when we will do the course of this deep learning and machine learning, but this is just an introduction to them. So we will have various algorithm that will set an optimal value for these weights and come up with the best possible iteration or best possible weights for these features, and we'll get our output based on that. So to name them, we have an algorithm called backpropagation. We have stochastic gradient descent that will perform and get us the optimal result for this neural network. So now coming to one example of deep learning, and this is like really happening in this world, in this unprecedented times, which we all are seeing, the COVID, the pandemic that has been rolled out. So just to imagine how deep learning is contributing in the research of the pandemic, or how it is helping the researcher, the medical professionals, is the live example which I have took of this data. And we'll be solving this problem in our deep learning course. This is like very interesting problem of detecting whether a person has a COVID or not. Like this is a quick test and the most accurate one, like most, I will not say most, but better accurate one, and to get the results at very early stage. So this data is available on Kaggle. So Kaggle provides you free or open source data. So it's a competition that they have organized, and these are real images. All real images they have provided of chest X-ray scans that these healthcare institutions have done, and they have made it public so that we can learn, or a model, we can build a model to help the healthcare professionals and doctors around the world. So these are real images of the real person who have undergone the chest X-rays while being suffering from COVID. So the photos or the inputs we have is a person is either having a pneumonia or a COVID positive or a normal thing. So a model is trained on these three images. So model will learn the patterns of these three, how the person with the COVID looks like, how the person with pneumonia looks like, and how the person chest X-ray image of a normal person looks like. So now imagine the model is built on, you can say, 10 millions of record, and we will completely build this model from scratch in our deep learning or machine learning course. So in our machine learning course, we will see an introduction to deep learning, and we will do this one example in that. So that covers from scratch, from collecting the data, from data pre-processing, from feature mapping, and then building a model. And I worked on this data and achieved an accuracy of 95%. So your model is 95% times right that a person is either COVID or not. So you will use CNN. CNN is nothing but your convolution neural networks, and this will help you to distinguish whether a person chest X-ray is a COVID or a normal person. So now coming to our ending slides, the steps, or you can say the building blocks of machine learning or deep learning, both will look like similar thing, or both will look like these steps. So this is very simple process that keeps you worrying about what is ML, what is deep learning. Just learn or just it, like feed in your brain these 7 steps. If someone says how machine learning works or machine learning model, deep learning model works, just reiterate these 7 steps. First of all, you will gather the data. You will prepare that data in terms of feeding to algorithm. You will pre-process, you will clean that data, you will do feature engineering. Then you will choose a model which you want to build. You either want to build a tree-based model, decision tree, random forest, XGBoost, or whether you want to do a deep learning neural network, you want to build computer convolution neural network, you want to do computer vision. So you have to choose a model. Then you have to do training. You will train the model. Then you will evaluate your model. How is it performing? And if the results are somewhat varying, you can tune the parameters. So hyperparameters are nothing but your model specification or your training specification things which you can tune something to improve the results. So then you hyperparameter tuning, you will improve your model, and at last you will predict what you want to predict. You want to predict house price, you want to predict cancerous cell, you want to predict loan defaults, and the use cases are endless. So that is the application of machine learning and deep learning. You can apply it to any business domain and use case. And we have covered it a little bit. We have seen the difference between machine learning and deep learning, and we know that based on deep learning, it is quite more extensive. It takes long time as we have several combinations to try out, and it takes really long. So the pre-trained model that Google and Facebook has released, they took them months to develop. So once you run the model, it will take months to pre-process based on the data you have. So they feed millions of records to build a very good models. So as you can see, that requires larger data, and machine learning requires less data, and it is a rule based and data driven, or you can say tree based. But that is your neural networks are black box. So they are based on your permutations and combinations and different combinations of weights. So training time is short and here it is long. So that is machine learning is good for classification task and clustering. So and when you want to do something with images, video, audio, and text, it is deep learning. Deep learning is widely adopted on all kind of unstructured data, image, video, and textual audio. So you will prefer the deep learning algorithms, and you can train on CPU. In machine learning it will take less time, and in terms of deep learning you will require your GPUs as well for training it, you can say in less time. So that sums up the whole this whole course. What is data science and what all subject or the things that you need to know. So this is the Venn diagram of data science. You need to know machine learning. If you have traditional software programming knowledge, that is really good. You will need to learn a little bit of maths and stats. You have some knowledge of computer science and the subject matter expertise. So that is really matters when you are working for some business domain. If you're working for business BFSI, that is banking finance, you should have a knowledge of how bankings and finance and this insurance institution works. If you're working with healthcare, you should know how this particular disease works and how to get distinguished and things like that. So that is subject matter expertise. So in this boot camp, we have done our first introduction to data science, and the next courses that we will be coming up with is complete Python boot camp that will start from very basic of the Pythons and covers each and every concept of Python. That is your OOPS concept, your classes, your files, your functions, your algorithms that are built in Python, and we will do one capstone projects also. So third one is your business statistics that will come with your statistics knowledge and your, you can say, hypothesis testing, your mean median, how the normal curves look like and whatnot. The other course we have, the fourth one is SQL, and that is really important when you are working in the industry. You have to prepare the data before building a machine learning model. So that is really a good skill you should know for becoming or getting your hands dirty in the data science. And at last we will see the machine learning, in which you will learn how to use that data and use that information and build a model out of that.